Power electronics, integrated circuit. An integrated circuit is a complete electronic circuit including all components of silicon only and wiring formed in a tiny chip of silicon only about 1 by 4 millimeter squared by 1 by 4 millimeter thick. The small chip is enclosed in a case typically 18 into 6 into 3 mm with about 14 pins so that it can conveniently reassemble into electronic equipment. There are two basic types of microelectronic circuit: monolithic integrated circuits and hybrid film circuits. In monolithic IC integrated circuits, all the circuit elements, both active and passive, are formed simultaneously on a small chip of silicon by the diffused planar process. These circuit elements are interconnected to form the required electronic circuit by deposited by the irradiation into the top of the oxidized surface of the silicon chip. Hybrid film circuits for micro miniature electronic circuits fabricated by forming the passive circuit components and metallic interconnections directly on the surface of a ceramic plate and then adding the active semiconductor devices in this discrete chip form. There are two types of hybrid circuit: thin film circuits, in which the passive component and interconnections are formed by evaporation, and thick film circuits, which utilize silk screen processor planar process. The sequence of oxidation, selective oxide removal, and diffusion forms the basis of the planar process, so called because all the device regions are formed by process carried out on the plane surface of a silicon slice. Diffusion solid state. It is a process which results in N-type or P-type impurity atoms moving into a solid silicon slice. If an N-type silicon slice is equal to high temperature in a gaseous atmosphere containing P-type acceptor element, acceptor atoms will diffuse into the silicon, and if the process is continued for long enough, the concentration of acceptor atoms in the surface penetrate into the silicon depends on the diffusion constant, the temperature of the silicon slice, and the time the silicon slice is exposed to the impurity. Ns is equal to N0 whole bracket 1 minus Er of x divided by 2 root of dE whole bracket, where Ns is impurity concentration at a distance x from the surface. No impurity concentration of the surface. D is equal to diffusion constants, convenient diffusant impurities which are compatible with silicon or boron as P-type acceptor impurity and phosphorus as N-type donor impurity. In practice, diffusion process is carried out in two steps. The first step consists of heating. The slice in a measured flow of impurity vapor for a short time to establish the required concentration of the dopant impurity on the surface of the silicon. This is called deposition step. The silicon slice is then removed and placed in another furnace where it is heated in a flow pure N, and the impurity atoms diffuse in from the surface to an extent depending on the temperature and time.